Welcome to the stream recap that I have to make because I forgot to record the whole thing. On the stream we were doing project Voxel, which is basically a base system for voxel games. For example, the most known one is Minecraft. So everything is made of cubes basically. But the base idea of this system would be not to just spawn Unity cubes, because if you would just make the two cubes, for example, let's center them and let's offset 1 by 1. Okay, so if you take a look, they look perfectly good. There is no seam between them, nothing. But if you would enter one, we see that the face inside is still rendered, and that can generate a lot more things to render if you would make a big map or a building or a spaceship or whatever out of these normal blocks. Because even a cube that wouldn't be visible at all, for example, would be inside something, would still be rendered. So instead of this, we are generating our custom meshes with code, and that allows us to save a lot of vertices and faces. The other thing is that this would allow us to would be harder for us to apply textures easily. That it could be done, but it would be harder. Our system allows us to apply the textures easier. So how are we doing that? We have 3 scripts for now. The mesh creator, voxel map, and voxel type. Voxel type is basically an enum that holds different types of voxel that we can have in the world. We have iron hull, steel hull, cobalt hull, because I was thinking about it like spaceship building game, and also a empty for block that was removed previously. And our voxel map has a dictionary of positions and the types of voxels. If the voxel is empty, it can either be not present in the dictionary or can be present with the voxel type empty. The empty, as I said, is set when we remove some block or we want to remove some block. And then we have a indexer that tries to get the voxel type, and if there is a voxel in this place, returns the voxel. If it's not, it's just air, so we return empty. It's not air. We return an empty voxel. We also have a method for setting the voxel with a parameter that is not necessary update, and it basically sets the state in the gets the state of the voxel current state. If it's the same state, it does nothing because it doesn't have to do anything, and then it sets the voxel, and if we need to update and the default is true, we update the map, so we recreate the mesh. We also have a demonstration method that showed us that we shouldn't update every time, because this method sets a big large amount of voxels at once, and if you would would update after every voxel, it would be super long to render because it would render the whole thing every time. And instead of that, we just update them up at the end, and we use the false here, so we wouldn't update every time. And we have a update map function that basically creates a mesh using a function in mesh creator, and then sets the mesh to be rendered. And in the start, we just create one block just to show it's working. As you can see, it's working. We can set another one, so you can see that there are no faces between them. Face is, well, the side of a model, and if we take a look inside, there are no faces, and that's what we want. And our mesh creator script is where the magic happens actually. So first we initialize three things: vertices, triangles, and normals. Vertices are the corners of a model. Triangles are the faces. It's an int because it specifies which like we add the ints in, let's say, pairs of sets of three, and it determines which three vertices it should connect to create a triangle or a face. Because in game development, every model is made of triangles. And then there is normal, and normals are basically how the light should be reflected or rendered. Without it, it would be just like a gray block. Like you wouldn't see the corners properly, all that stuff. I can show later. And then we have our for each loop that gets every voxel. Then it filters. Oh, there is a problem. Where x dot value not equals empty. So it filters that it shouldn't be empty. This is just a SQL function that says take the every value and pass only the one that will get this as true. So everything except empty. And then for each non-empty voxel we get the face. We just enumerate through a enum that is specified here. So north, south, east, west, up and down. We get the direction that we can check here. It's basically a big switch. Check if the neighbor, the voxel in that direction of the original voxel is present, and if it's present, if it's not present or it's empty, so well, it's empty because this will return the state. If it's present, if it's not present, it will return empty. So if it's empty, we render the face, and the render face takes a lot of arguments. It takes the position of the voxel, it takes the face of the voxel, takes the mesh vertex, the mesh triangle and mesh normals. These two are just for rendering, and these three are to return the values. The ref keyword means that it will, if we change something in this argument, it will also change here because we passed these values. So it will change the original values, not the copies. And then we get the vertices of the faces. These are just hard typed positions of the vertices in clockwise order. Because it's easier for us then to create the triangles, and offsets them by the vertex position. So every vertex of the voxel position, because we don't want every voxel in the same place. We get the current count of mesh vertices that will be used further in the script, and then we add our vertices of the face to our mesh. You can probably see that that means that we create 4 vertices for every face, and if you remember, a cube has only 8 vertices, but this approach allows us to add different textures to different faces, to be explained in the next stream that will be uploaded here. Then we create normals. Normals are basically the direction the face is facing, and that's easy because our model is a cube, so we can just return at the direction of the face, and we add the normals, and then we create the faces. We got the current index, and then we added the vertices. So to connect it, we can just add these 6 values, because to connect, because it's it's clockwise. It will add the top left, top right, bottom right. So it will create one triangle, and then it will add top left, bottom right, and bottom left. So it will create the second triangle, and it has to be clockwise because otherwise the face, it will render the other side of the face, the inside one. And that's it. And you just create a new mesh and set the values. You have to cast to an array, or rather change the list to an array, so because the mesh wants an array, not a list. And that's it for this part. In the second stream, we also did textures. We also did fix some potential errors that would be present if we would make too big of a object. Well, try to place an object, and we added placement of the placement and removal of the cubes. So go ahead and check it out. I will upload it after this recap. Sorry again that I didn't upload the original stream, but I forgot to record it. You can check out my streams every 11:30, I think, UK time. And you can check out the code in the GitHub, also linked below. So yeah, that's it. Bye.